All right, today we are unlocking one of the most powerful tools in your entire calculus toolkit, the substitution rule. Seriously, if you've ever been stared down by a really complex integral and just felt stuck, this is the technique that's going to completely change the game for you.
So let's just kick things off with a puzzle. Take a look at this integral. It looks a little intimidating, right? I mean, you could try to expand that parentheses to the fifth power, but who has time for that? And our basic integration rules, they don't seem to apply directly. So how in the world do we tackle this thing?
Well, the secret? It all lies in thinking backwards. You already know the chain rule for taking derivatives of composite functions, functions that are tucked inside of other functions. Well, get this. The substitution rule is simply the chain rule, but in reverse. It's our secret weapon for integrating those exact same kinds of functions.
And you can see that connection so clearly right here. On the left, we've got the good old chain rule for differentiation. And on the right, the substitution rule is its perfect mirror image for integration. We're literally just undoing the process.
I absolutely love this analogy. Think of it like this. You're looking at a super complicated picture, and it's kind of a mess. But then you put on a special pair of U glasses, and bam, all of a sudden, everything simplifies. That is exactly what we're doing here. We're swapping a complex expression for a simple little variable U, just to make the whole problem manageable.
Now, the best part about all this is that it's not guesswork. Not at all. There is a clear, repeatable, 5-step roadmap that you can follow every single time to solve these problems. So let's walk through that right now.
Okay, here's our game plan. First, you identify that inner function and you call it U. Second, you find its derivative, du. Third, you do the big swap. You substitute everything to transform the integral into the nice, simple world of U. Fourth, you integrate that new function. And finally, you substitute back to get the answer in terms of your original variable. That's our roadmap.
All right, Siri is great and all, but let's actually put this into practice. We're going to walk through all 5 of those steps with our first example, and this one involves an exponential function. So here's our problem. We're looking for that inside job, right? That composite function. And in an exponential function, a huge clue is that the inner function is almost always the exponent itself. So our first step is super easy. We're going to let u equal 4x minus 1. Step 2, find the derivative of u. Well, the derivative of 4x minus 1 is just 4. So we write du equals 4 dx. Now here comes the crucial moment. Look back at our original integral. We have a 4 and a dx sitting right there just waiting for us. It is a perfect match. This is the green light that tells us substitution is exactly the right move. Now for the magic. We replace the 4x minus 1 with u, and we replace the 4 dx with du. And look what happens. Our complicated-looking integral just transforms into, simply, the integral of e to the u du. And we all know that's one of the easiest integrals in all of calculus. It's just e to the u plus our constant of integration, c. For our final step, we just need to go back to our original variable, back to the world of x. We just replace u with what it originally stood for, which was 4x minus 1. And there we have it, our final answer, e to the power of 4x minus 1 plus c. We successfully navigated the 5-step process. Okay, let's level up. This powerful pattern isn't just for exponential functions. It works for trigonometric functions, power functions, you name it. Once you recognize this pattern, you can apply it pretty much anywhere. Just look at how versatile this method is. For the trig example, the inner function is x cubed. Its derivative is 3x squared dx, which is sitting right there in the integral. It's perfect. We just integrate cos of u to get sine u, which gives us sine of x cubed plus c. Now what about that power example? Hey, that was the problem we started with. The inner function is x squared plus 1. Its derivative, 2x dx, another perfect match. We integrate u5 to get u6 over 6, we back substitute, and we're done. See the pattern? So the most crucial point to take away from all this is simple. U substitution is really just a perspective shift. It's about training your eye to see that function within a function pattern. Once you spot that inside job and you see its derivative hanging around, you can transform a problem that looks impossible into one that is, fundamentally, really simple. This technique is so much more than just a trick to pass your calculus exam. It's a way of thinking about problem solving, of reframing a complex system into much simpler terms. So I'm going to leave you with this question. Now that you know how to change the variable, what other complex worlds can you simplify?